oil and gas field, which is now held on this special day at Zoom meeting. It is truly an honor to gather here with all of you for a day full of insights, learning, and some meaningful exchange. Before we begin, allow me to acknowledge and welcome our honorable guest and speaker. There is Mr. Riky Bernardo, Chartered Engineer and fellow ICOR, as our keynote speaker, and Mr. Muhammad Waldi as a lecturer from Metallurgical Engineering, University of General Ahmad Yani. And then there's Professor Dr. Bambang Widianto, DEA, as our faculty advisor of AMP Student Chapter, University of General Ahmad Yani. Also, there is Mr. Yuda Pratesa as the AMP Indonesia representation. And then there is Keisha Sandia as our chairwoman for the AMP Student Chapter, University of General Ahmad Yani. Thank you for your presence and support. To officially open our event, I would like to invite Mr. Muhammad Waldi, a lecturer from Metallurgical Engineering, University of General Ahmad Yani, to deliver some welcoming remarks. Please give a warm round of applause to Mr. Muhammad Waldi.
Thank you very much, Jehan. Good afternoon, everyone, ladies and gentlemen. Thank you to each and every one of you for being here today on April the 10th, 2025. My name is Muhammad Wadi, representing Mr. Chairman of Metallurgical Engineering Department of Universitas Jenderal Ahmad Yani, who cannot attend this afternoon webinar. It is such an honor to me for me to speak on behalf of the organizer. Let me begin by giving you a warm welcome to the Corrosion Navigation in Oil and Gas Field webinar, organized by the student chapter of the Association for Materials Protection and Performance, AMPP of Universitas Jenderal Ahmad Yani, Bandung. So before we get started, I would like to express my appreciation to the faculty advisor of AMPP student chapter Unjani, Professor Bambang Widianto. Thank you very much, Pak. And representative of AMPP Indonesia chapter, Pak Yuda Pratesa, and also keynote speaker, Mr. Riky Bernardo, and all 283 registered participants from all countries, campus, and industries. In today's seminar and today's webinar, we will have an update information and progress in corrosion engineering disciplines, focused to the corrosion navigation in oil and gas field. And I hope that this webinar will help you to build your awareness in corrosion mitigation. Well, I do not want to make you too much of your time. I need you to hand over it to the organizer. I'd like to say once more on behalf of the organizer, welcome and thank you. And it's a great pleasure to see many of you here. Thank you very much. Johan.
Okay, thank you so much, Mr. Muhammad Waldi, for the thoughtful words that you've given to us on the opening speech. The next is Professor Dr. Bambang Widianto that will give some opening speech to us.
Okay, thank you, Jihan. So, good afternoon for all participants. Thank you for your participation in this webinar. So, I know Mr. Ricky long time ago. We worked together, maybe sometimes Pak Ricky. And I think he has many experiences in corrosion because he worked always in oil company. So it is very useful for us to hear the presentation from Mr. Ricky, and he can sharing his experiences for us and give a motivation for our student. Maybe we can add many students who has the interest in corrosion. So I'm very happy for this opportunity, and I hope we can have many discussion with you. And please share all your experience to us. Thank you very much, Jihan, and welcome, Pak Ricky. We hope we can meet again in Indonesia next time. Okay, thank you.
Okay, thank you so much, Professor Dr. Bambang Widianto, DEA, for your opening speech. It is such thoughtful and meaningful words that you've given to us. The next one is I would like to invite Mr. Yuda Pratesa from AMP Indonesia to give an opening speech to this webinar. To Mr. Yuda Pratesa, you are allowed to open your mic.
Okay, thank you. First of all, I would like to say congratulations for the committee, because you already make a very good meeting. I think around more than 100% come to the meeting today. And I would like also to say thank you to Professor Bambang Widianto as the student advisors.
Yeah,
So
you're welcome.
it's nice to have a collaboration with Universitas Jenderal Yani. They are very, very active students. And also, of course, I think this is the second time we met Mr. Riky Bernardo.
Okay.
He has a very, very lot of experience. I think you are still on the Middle East until now, right?
Yes, still in
Yeah,
the
okay.
same company where we
Okay.
both
So not
work.
changing.
Yeah.
Okay, yeah. So since he has a lot of experience outside, so I hope all of the student and participant here will gain a lot of expertise from him. Yeah, a lot of experience. Not only maybe you already learned in the book, from the lecture and so on, but with this seminar, we hope that you can get more experience, in the real application in the field. Yeah, so. Enjoy this meeting. Yeah, I hope you got many inputs and a good experience for this meeting. Yeah, thank you very much.
Thank you very much, Mr. Yuda Pratasa, for your opening speech. It is really such meaningful words that you've given to us. The next is I would like to invite our chairwoman, Keisha Sandia, to give an opening speech to the webinar.
Good afternoon, everyone. It's a pleasure and an honor to welcome all of you to today's webinar, proudly hosted by the AM Student Chapter Universitas Jenderal. Our topic, corrosion navigation in oil and gas field, explores one of the most vital aspects in the oil and gas industry, how we manage corrosion to ensure safety, reliability, and performance in the field. We are incredibly honored to be joined by Mr. Riky Bernardo, C.Eng, FICorr, a chartered engineer and fellow of the Institute of Corrosion with over 25 years of experience across major global companies in the industry. What makes this session even more exciting is that it's not only about technical insight, it's also about personal development and how we can grow to meet the demands of a global industry. Before we begin, I'd like to extend our heartfelt appreciation to our faculty advisor, Professor Dr. Engineer Bambang Widianto, and of course to our metallurgical engineering lecturer, Pak Waldi, and also our mentor and Indonesia representative, Pak Yuda Pratesa, for their continuous guidance and support. And also I saw in the audience, there is Pak Panji, who is our respected mentors whose support and guidance mean a great deal to us. And of course, a special thank you to my incredible team at AMP Student Chapter Unjani. Your dedication, creativity, and teamwork have been the backbone of this event. With that, I wish you an insightful and inspiring session ahead. Let today be more than just a webinar. Let it be a spark for your next big step in the world of corrosion and beyond. Thank you.
Thank you so much, Keisha Sandia, for your opening speech. Now, I would like my colleague, Dura, as the moderator, to conduct the next session of the webinar.
CV-nya saya. Di PowerPoint.
Thank you, Jehan. Mr. Riky Bernardo is an Indonesian citizen born on 27 January 1976 in Bandung, graduated from Chemical Engineering of Parayangan Catholic University in 1999, and currently living in Qatar and Oman. Mr. Riky Bernardo is also a Chartered Engineering Council, United Kingdom, and a Fellow Engineer Institute of Corrosion, UK, certified in 7 NACE or AMPP, including NACE Corrosion Specialist, 2 API, and 2 IndoCore certification programs. Mr. Riky Bernardo has some experience and achievement, having 25 years of experience in oil and gas industries, experience in facility engineering and corrosion engineering, deal with crude oil, sweet, sour, and LNG processing facilities, having experience in various department operation support, engineering excellence, operation technical, maintenance, and asset integrity. Thank you, Yura, for telling us about Mr. Riky Bernardo. And now, finally, it's time for the webinar to start. To Mr. Riky, stage is yours.
All right, thank you. Let me share one presentation. Okay, just please confirm whether my presentation is already displayed and you can see it through your screen. Jehan, please cross check.
Done.
Done. All right.
Seen.
Thank you. Great. So first of all, I would like to say thanks to all of you here. Of course, AMPP Indonesia chapter, Unjani, and then everybody that I cannot mention one by one for this fabulous opportunity to share my field experience with all of you. There will be 2 presentations today, and we are going to complete it within probably around 2 hours. And I believe after 2 hours time, there will be some session question and answers where you can note it down all of your question for a while. So at the end of the presentations, anybody who wants to, raise any questions, you can raise. So I would like also to welcome everybody, which is who are coming from outside Indonesia. So do not hesitate if you have any answers. So please speak up. So we will try our best to explain it to the best of my knowledge. Thank you so much. So the first presentation is slightly technical. It is not deep. I can say the first presentation will give you a general summary about the corrosion engineering in oil and gas industry. It is more general, cover most all of the aspects, but not that deep. It is very well suitable for you who are just starting your career in oil and gas, and also for somebody who are already experienced in the industry, but not specifically working in corrosion and material integrity. So let us start. So topic of discussion today, we are going to discuss, as highlighted here in the first page, pre-introductions, and then fundamentals, reactions, slightly corrosion in oil and gas industries, and then prevention and mitigations, monitoring, inspection, predictions. Also, I would like to give you some summary about the corrosion cost, and both for USA and worldwide. And the next one is the corrosion clue. Okay, before starting, I would like to show you 2 famous picture that I took from an open website. So you can see the source of the website where I took it. It's from corrosiondoctor.org. So what is this? So the first one is Carlsbad explosion, and the second one is the Guadalajara explosion. And those two are related with corrosion. And those who wants to know detail, you can read it by yourself. And those two cases are just an example amongst probably hundreds or thousands cases around the world that is keep happening. Even today, we don't know, who knows, today, at this time, at this second, something is happening. So it could happen to any organizations, both small organization or a giant organization, in any countries, regardless. They are considered as a third country or top tier country. Accident is accidents. Okay, so I can say that corrosion action doesn't have an holiday, doesn't consider night or day, and doesn't consider where you are. It may happen anytime. And you can see it's quite a severe punishment for anybody who neglected. Let us start with fundamental and definition. Corrosion is nothing but a physical deterioration or degradation of metal. And its properties, why? Because it is arising from the interaction with the environment. So you guys can imagine it's an spontaneous phenomena, naturally happen, and we can only deaccelerate it, not to stop it, not to 100% eliminate it. It is like a natural phenomena of human becoming old. Yes, you can buy a lot of cosmetics, you can spend a lot of money, you can spend a lot of efforts in gym, visiting a very good and well reputable hospital and doctor, but someday you'll become old anyhow. You can only to make it slow down, not to eliminate it. And nobody wants it, but it happened. So from the perspective of electrochemical, this is nothing but corrosion between anode and cathode, where we know, and a lot of, you can also see in a lot of handbooks that the anode is actually releasing electron, and the cathode is actually capturing the electron, and then the reactions continue. The other one supplying electron, the other one consuming electron, and if both are connected in one electrolyte, then the corrosion will continue until the anode is completely consumed. So what is electrolyte and what is anode and cathode, and what's the reaction between them? We can see in the next page. So as I explained before, there are 4 major requirements for corrosion to occur. So first, you need to have anodes. Second, you need to have cathode, and the famous one, electrolyte, usually in water. And both anode and cathode has to be connected. Okay, if we eliminate either one of the factors, then the corrosion will stop because the reaction cannot continue. Why? Now, the question is why there is an anode and cathode. It could be several reasons. The very obvious one is because of we connecting two distinctive metal, which is clearly different between them. I took an example here. One is carbon steel, and the other one is austenitic stainless steel. They came from a different species where we know they are having a different electromotive force, where stainless steel, austenitic stainless steel, is more cathode, having more electropositive, while the carbon steel is becoming anode because it has more electronegative in one system. So if you connected carbon steel and stainless steel and you put them together in an electrolyte, either water or soil, which is having hygroscopicity, or we could say wet soil that again inside the water and soil, of course, we have anion and cation where can deliver the current. Then the corrosion cell and corrosion reaction, likewise I explained in previous page, occur. The second point is it looks like only one metal, okay? But don't forget that during metal manufacturing, actually there are some impurities that are possible to be attached to. This is, unintentional. We call it other metal impurities, unintentional, because of probably during fabrication, it was not clean enough to clean your machines or to clean your casting equipment, or even during construction or maintenance. Okay, that the other species of impurities attaching into the base of metals and creating cells, which is having a different electromotive force with the original base metals, and again causing the same reactions occur. And another fact, the third one is a bit difficult, but just to say when we see a perfect shape of metal, everything are clean, everything are perfect, and looks like very homogeneous. But even in that case, if we cut a specimen and if we observe that piece of samples underneath the microscope, and you enlarge them 100 times, 500 times, or 1,000 times, or even if you want to be more clear, could be higher than 1,000 times, then you can observe that actually they are not homogeneous. As we know, for instance, carbon steel, it consists of pearlite, which is Fe3C and Fe alternately. And even Fe3C and Fe, which is cementite and ferrite, are having a different electromotive series, which is the Fe3C will become cathode and Fe will become anode. So by the time the material getting aging, it may self-corrode because of that. So we can see two different examples here. The first one is a theoretical electromotive series from theoretical, mostly high school or early basic elementary chemistry. We can see that top to bottom, from potassium to aurum. Aurum is nothing but gold, if you know gold. So today the gold price is soaring. So gold is famous, but when we talk about aurum, I think not many people knows aurum, but aurum is nothing but gold. And potassium, or sometimes in Indonesia we call it kalium. Okay, you can see that there's a number beside every element that we wrote here. So from negative and going further down to bottom, it's become more and more positive. So from top to bottom, we can see it's having a very high energy, which is very active or unstable, easy to release electron. And going down, further down, into more passive or stable. Okay, so if we select two elements between them, let's say we select magnesium with argentum. Argentum is a silver. Which one's going to be corrode? So the easy to remember is it's always the more bottom one minus the top one. So it's always the active one or unstable one going to be corrode. Okay, and the further you select the two element, the further the distance, the corrosion reaction will become faster. And the faster they are not getting corroded. Let me give you an example. If we connect magnesium with argentum versus we connect in second case, let's say we connect zinc with chromium, which is they are close, the corrosion reaction in aluminum and zinc will be much slower than magnesium versus argentum. This is how we consider, and the right side is nothing but the same. If the left side, we are talking into more theoretical single element. As we know, in the real industry, we never have a single element in our metal. Our metal is always consists of various elements called alloy. And in the right side, it is more into the actual industry where you can see there is a carbon steel, austenitic stainless steel, copper, nickel, nickel-based alloy, martensitic, ferritic, and so on. But the working principle, the way we explain, is the same with the theoretical element electromotive series, like I explained. From here, we continue to corrosion in oil and gas industries. The simple one, it is happening everywhere. Whether you are in upstream, starting from the very most upstream one, we can start from a production tubing, for instance. It's a very upstream until the very most downstream one, refinery and petrochemical. It's everywhere. Amongst all of the example, I would like to bring a few picture here. We can see some corroded production tubing in your top left. And then moving to your right side is shell and tube exchangers where the tube bundle was being removed from the shell. And we can see a rusty color. And the third one is the subsea pipeline, which is no longer used. And you can see it's a through hole. Corrosion is everywhere. And moving forward to the right side in the middle of this page is the hull of the ship, which is totally damaged. And then next in the right side, the only pictures in the right, it's a pile in the port, which is also experienced corrosions. You can see bolt and nut, and then storage tank in a refinery, which is storing your petroleum product. So would like to highlight that corrosion is everywhere. What are they classified with? Normally, we classified them based on three different type, which is low temperature corrosion, medium temperature or normal temperature corrosion, which is in between 4 to 200. And the last one, higher than 200, everything higher than 200, we classified as a high temperature corrosion. So what are they? Here you can see general and localized. And then we have also pitting and cracking. So many acronym here, HIC, SO, HIC, CSS, SCC, SSCC, FCC, and so on. We can learn one by one later in next page. We have crevice corrosion, blistering, lamination, embrittlement, and so on. And in high temperature, which is again, I repeat, high temperature, we classified more than 200 degrees centigrade, or API 571 says that 204. But let's not to debate about whether 200, 204, or it's just we can just mention that approximately around that temperature limit where the damage mechanism is slightly different. We have a scaling, which is nothing but high temperature oxidation. We have creeping, intergranular corrosion, sigma paste, grapitization, sulfidation, etc. Well, for the low temperature corrosion, which is normally occur in sub-zero temperature, it's a very famous one called a brittle fracture. So we have some picture showing, not representing all that I wrote before, but we can see some pitting corrosion, some localized corrosion, some cracking. There are straight cracking. There are branching like thunder. We have also hydrogen-induced cracking or blistering in your bottom. And we have also stress-oriented high-induced cracking, which is in the most right side. Okay. Further, we can see embrittlement in your top lab. And then you can see intergranular corrosion when we observe under the microscope. We can see the third picture for lamination, which is your piece of metal separated into two. And in the started with the tiny and small bubbles and then become larger. And then the huge pressure, internal pressure of the trapped hydrogen push the material toward, direction. Then it's caused significant lamination and finally separated out. And the last picture, you can see a brittle fracture where the metal is become very brittle from normally ductile into very brittle. So it's like a crackers or glass. When you slam the glass to your table or to the floor. So this is exactly happening without the thinning, without the loss of thickness of the material, it will break because it's lost its ductility. So normally in our industry, we always try to mitigate, to avoid the failure of the equipment. We started with the causes. If you can see here, the causes. What initiate the failure? That's the meaning of the causes. It could be because of inherent material issue. It could be because of anything that we wrote here. You can look at it one by one. It could be in combination between more than one of them, or it could be only one enough to cause or initiate the failure. Then what happened after that? Then it will become thinning, cracking, or crevice, or pitting, etc. This is, we call it corrosion damage mechanism, or why failure happened. Next, further, failure mode. How the failure happened. At the end, what happened? It's leaks, holes, or rupture. Okay, and equipment collapse. And the incident may cause a fire explosion or loss of containment, liquid and gas release to environment. And at the end, equipment asset damage, production loss, or even loss of the reputation and company stock fell down and bankruptcy and so on. So this is a circuit that we would like to avoid. How to avoid? The first one is we prevent. Prevent means always to stop the cause from beginning, for not happening. So prevention is always a preferred method because it is the cheapest one. Okay. Once it's already started, it's already thin, it's already cracked. So in order to stop the propagation, to make it become worse, then we call it both prevention and mitigation, which will cost you more than just a prevention. We can see the sign of dollar here, one, and I make it a distinctive different color to differentiate them. Now the dollar become two, which is just, this is non-quantitative comparison, just to highlight that prevention and mitigation will, of course, will be much higher cost than prevention. Now, if it is already leaked, then it is even more expensive. Okay, you can see here mitigation and recovery. What we can do is just, it already happened, let it happen, but let us reduce the effect. And this is much, much more expensive than the previous two. But if it is already exploded, already released, already affect the environment or people or the company, then you can only do recovery. Then nothing much we can do. We accept all of the result from the incidents. So now we no longer speak about the money. We no longer speak about the effort. So it's already happened, and 100% we accepted the result. So this is all from causes up to the final results. This is where material integrity and corrosion engineers are playing in this area. We are working how to stop since beginning, or even participating just in case we cannot stop this whole circuit and reach unto recovery. This is why our material integrity and corrosion engineers, this is why our expertise is needed in the company. We have 7 to make you easy to remember. For corrosion prevention and mitigation, we have 4 plus 3. Top 4 plus 3 addition, so total 7. Top 4 corrosion prevention methods are nothing but material selection, coating lining, CP, or we call it cathodic protection, and chemical treatment. While the 3 additional, normally we play with the design, we play with the parameter control, which is more into the operational, and we play with the mechanical treatment, which is we manipulate the mechanical properties of the metal. What are they? We go one by one. For material selection, should always be the first option, because that's why here I brought into attention that material selection is always in the first row, because the material selection is considered to represent 95% of the case where during front-end engineering design, we have to select the right material. So why not 100%? Because we know nothing is perfect. Sometimes we miss out something. Sometimes we underestimate something. We think like the process will not be that corrosive, but at the end, somehow it is not as per our original prediction. So we still consider more or less, again, some companies says that 90%, some company 95%, but I'd rather to select 95%. So between 90 to 95%, it has to be selected during fit. And the rest, which is 5 to 10% probably, we'll have to upgrade it during operating phase. But again, when you are coming into operation phase, in order to upgrade the material, you will need to interrupt. You will need to stop your productions or your operating activity. In that case, you will lose production. You will have a higher risk on exposure because the material already exposed to fluid is going to be risky and more costly. It's always good if you can, even though not possible to reach 100, but we try our best to always to select the correct material since the beginning. Okay. There are various standard and guideline. I just want mention here for ISO 15156 or MR 0175. This is just one example, but there are a lot of many standards related with this material selection. Okay. I would like to bring into here a few examples because in reality there are hundreds of them. This is just few examples just to give you an idea how we select the material. For instance, carbon steel for low temperature application, we are using SA516, and then for high temperature, we are using SA515. And so on. We can see here upgrading the class to austenitic stainless steel 304, 316, and then getting up into low carbon version of them, and then high temperature application for austenitic stainless steel. You can see ending up with H, 304 H, 316 H. This is the high carbon version, which is giving you a stronger resistance of high temperature damage of the austenitic stainless steel. And we can see 321, 347. This is the modified austenitic stainless steel by adding some rare element like tantalum, titanium, in order to avoid the intergranular corrosion. And even higher than austenitic stainless steel, we may have nickel-based alloy. I just mentioned here two examples, Inco alloy 825 or Inconel 625. But in reality, there are hundreds of types of nickel-based alloy. And higher than that, for example, titanium, or even we are using platinum. And sometimes we are using gold. Okay. So we use a lot of different metal. I just mentioned here metal, but in reality, we have also a material from non-metallic group where we will explain later. And the basic concept of selection of material selection. Just example here for metallic material. Normally, we started whether we need carbon steel or we need CRA. What is CRA? Is a corrosion resistant alloy. From where it is normally from the study, what will be the liquid, what will be the composition, what will be the water cut, what will be the temperature and pressure, what will be the SCO2 and H2S content, what will be the gas to liquid ratio. We collect all of them, and also along the design lifetime, let's say what will be the design lifetime, 25 years. Normally we took an average for a medium or very common oil and gas design lifetime, 25 years. And there is a plot of all of the data that I mentioned for every year. We call it POD. And from there, we will know in the early production stage up to the nearing end of the desired lifetime. So we consider all of the situation and condition. Then we calculate corrosion rate. We can use corrosion modeling. There are few corrosion modeling available in the market to calculate the estimation of the corrosion rate. And from there, we will know the approximation of the corrosion. And from there, we can see also with a lot of other consideration like material availability and of course, cost approval, because there will be some optional for you, whether we are using the highest material, means highest capex, capital expenditure, because of course the higher metal will give you a more expensive cost to spend in the beginning of your project. But you will get a low OPEX, low operation expenditure at, after the project is completed. By means you spend a big amount of money in the beginning, but then to maintain it, you will require slightly lower cost, or the other way around. You just buy lowest material, which is normally carbon steel in this case. The capex is low, but your OPEX going to be high because you need chemical treatment, you need coating, you need cathodic protection, or you need a lot of inspections interval within the desired lifetime. Then from there, you will select which option are you going to take. If it is decided finally by management that we are going to the highest metal, then you will have, for instance, a post design of all high grade of metallic material, okay, like nickel-based alloy, for instance, and you will have a very limited maintenance requirement, and so on. But it's not only about the cost, but availability of metal. For some instance, in certain region of the country where access is an issue, it is not really having easy access to get the material on time. So some material like nickel-based alloy will give you a very high lead time. It will take like probably 2 years, 3 years to get the material, and it's become very expensive. So normally that decision also will affect that factor also will affect the decision on selecting the material. But if your region is located in the center of the world, in US or in Singapore or in Dubai, where it is easy to get any material, normally it's not an issue. And also easiness to weld, because construction requiring welding activities, and not all material can be welded. And if you want to talk about the machining, there are pre-machining grade and so on. So there's a lot of consideration. And this is material family tree. You can see here, material is not only metal, but we have also non-metal. I already explained about the metal previously. We can see from the color code here. And while the green one is a non-metal, we have wood, we have glass, composite, polymer, rubber, etc. So we are very wide, and we can even break it down into unlimited number. For instance, composites. There are probably right now hundreds of composites. Rubber also, it looks like simple rubber. Rubber is rubber, but there are so many classes of subclasses of rubber. And each of rubber has its own weaknesses and strength against the environment, against the temperature limit, against the pressure, against the compatibility, against the process, certain chemicals, and so on. Some rubber okay for certain application, but not for the other application, and so on. So we can see also some example of material selection. We can see here how we differentiate between austenitic, duplex, ferritic, martensitic, and precipitation hardening. Just the easy one, for instance, martensitic, it is not credible for welding connection. So normally we use martensitic only if we connect them by threading connection, not by welding. And then ferritic normally not for what they call not to be selected for high pressure application for pressure boundary, but it is only selected for spare part or internal spare part material, which is only experiencing compressive stress, not for tensile stress. Because different with austenitic, where having austenitic can give a very good toughness, where not easy to have brittle, but ferritic is not for such application. It is only for the compressive material, not for the tensile, and so on. talking about the austenitic stainless steel family, the very basic one is 304 or UNS S30400. We call it Unified Numbering System 304 S30400. It's a very basic one. We know them 18.8, 18% chrom, 8 nickels, 8% nickels. And then how to make 316 from there? We add moly 2% to 3%, then it's changed into 316. And then how to modify them if we want to avoid the intergranular cracking because of welding, we reduce the carbon, then it's become L version, and so on. You can add some tantalum and so on, then it will become 321, 347. And we can see here 310. 310 is also very famous. Is it here, 310? Well, it is not here, but 310 is normally for higher temperature. You normally use SS310, 310 for flare tip, where it can expose to more than 1000 degrees centigrade without failure. And here underneath of the page, we can see some example of the duplex stainless steel, starting from the plain one, which is 2204. 2205, sorry, and then normally we call it normal duplex. And actually there is a lower lean duplex, we call it 2101, but it is not written here. Then 2101 and then 2205 as a normal duplex. And then super duplex, sometimes we call it 2507. And then recently there are even hyper duplex, 3207 or other grade. So this is, keep evolving. Every time, perhaps today there will be new product. So we need to upgrade ourselves. We start to enter coating lining as the second prevention method after material selection. Coating and lining, just to make it easy, it's a primary corrosion prevention after material selection. The simple thing is to barricade the metal from its environment by coating. So it looks like so simple, just coating. Think about your fence of your house, of course, your fence mostly from metallic. Some I know some fence made from woods, but let us think about the metallic fence for your house. It's getting to corrode if you are not even maybe 2 months after the construction, it's going to corrode fast if you are not coated it with some coating. So it's just simple, the same thing. The only difference is for oil and gas, the environment is more severe than your house, than the fence inside your house. Why? Because there's a lot of contamination from gas, which is a high number of chloride, high number of NOx and OX or SOX, sulfur dioxide, sulfur oxide, and so on, which is causing your coating deteriorated faster than your fence, than the same coating in the fence. That's why the coating selection in oil and gas is much more critical than selecting the coating in your house. And also, just to remember, especially in downstream oil and gas industries, we are using a lot of acids and basics. And we modified the operating condition such a way to favor the production of certain products. So you need to either to bring it down, bring it up, lower or higher the pH. Then it is become a threat for your coating. So world of coating and lining, all manufacturers are now competing to keep producing more and more product which is resist with all kind of application as needed in oil and gas. Not I mentioned about the mechanical or abrasion, because some coating has a certain properties which is giving an extraordinary abrasive resistance. extraordinary mechanical resistance, and so on. And the application is not easy, first of all. No matter how good your coating is, no matter how correct your selection, but if you are not cleaning the surface, or we call it, if you are not doing the good surface preparation, the coating will not intact, and it will prematurely damage in much shorter range, interval range than it's supposed to be. Let's say from 10 years based on the design, then only 3 months it is delaminated, and then you're concerning why the coating is expensive, and we are correctly selecting the product based on the manufacturer recommendation, but still fail because of most of the failure cases of the coating because of improper surface preparation. And also the application is not easy. Some inexperienced people versus subject matter expert in that area, which is really know how to apply their product, you will have totally two different results, even you are using the same coating. So follow through the coating manufacturer and follow through a strict recommendation from standards, and use the high skill, expert to apply your product for the coating. So again, this is an example of the coating normally we use. Normally coating classified in three different application for external, which is atmospheric exposure. And then second classification for immersion, which is immerse with the fluid or with water. And the third one is buried. Buried means under soil normally. And again, the same thing with the material. Is limited by operating condition, mostly by pH and temperature. And coating never been applied in oil and gas in single layer. Only few cases where we apply coating in single layer. Normally, there are at least 2 or 3 layers where we call it a base coat, and then a mid coat and top coat, because every function of the layer are different. Okay, and give you a symbiosis, what they call mutualism symbiosis between layer to provide best performance as per the requirement in our field. And the coating application also evolved from the very beginning, 1970s, 1980s. We are using brass. We are using what they call hand only. And you can see the technology is evolving. We are now using a laser. And even there are we call it thermal spray, where we are no longer using liquid as a coating. Even you can use a metal itself. You crush the metal, make it become powder, become tiny powder, and then you heat it more than or higher than the melting point of the metal. And then in high speed, high pressure, you project it, the melted metal, into the surface of the coated equipment. Then it become a metal coated another metal. So there are a lot of application recently, which is we moved from the brass and normal hand application, from the air and compressor. Some now we mostly use airless compressor coating. Of course, this is selected to be well suited with your product. We enter the cathodic protection. It is nothing but electrochemicals method to protect the equipment from corrosion. It could be internal and could be external. It's nothing but using an equipment and provide an electron supply. If we come back to the previous slide, the very beginning of the presentation, where the anode is releasing electron. Because of the cathodic protection system, we add something, we call it sacrificial anode, for instance. Then the sacrificial anode will supply the electron. So instead of the anode, the original metal anode releasing the electron, this sacrificial anode will release the electron. So the actual equipment will no longer become an anode. And the corrosion reaction is stopped because of the anode until the sacrificial anode completely diminished. And of course, we monitor. We can see from all the data that we have that, oh, okay, our cathodic protection system need to be replaced or need to be upgraded. Then we replace before the anode is completely consumed, for instance. There are two ways, impressed current normally using external electrical source from alternating current. We use what they call transformer rectifier to translate it into direct current and to reduce the voltage from high voltage into low voltage. So the product is a low voltage direct current DC, and then the DC will be impressed by the anode, which is the anode normally inert, different with sacrificial anode, where sacrificial anode is depleted and consumed at the end. For impressed current cathodic protection, normally the anode is inert, which is made of mixed metal oxide or ferrosilicon or titanium, which will not be depleted. And the source of the current here is actually from the cross country line upstream of the transformer rectifier. So the only way is just to maintain the TR performance in order to be able to adjust the current and to deliver the current as needed. And not the anode. The anode normally is not consumed for impressed current. So this is how we select when are we going to use SACP and ICCP. Again, we are talking about OPEX and CAPEX. We are talking whether the cross-country line as the source for the ICCP is available, because in some case, in the middle of the sea, where we don't have a source for the electrical current, of course, we cannot use ICCP. Whether the structures to be protected is small or large, because the SACP is actually well suited only for smaller equipment, and ICCP is giving you more high efficiency towards the larger equipment and so on. You can see example of the cathodic protection starting from buried under soil for pipeline and jetty pile and subsea pipeline. So the tricky way is only one. If you are using cathodic protection, you need to ensure that the protected structures is connected to the electrolyte, because without connection with electrolyte, the system will not work. So, for instance, the correct example, if your pipe is constructed above ground, and between pipe support and your pipe, there is a non-metallic insulation, and it is sealed perfectly. So your pipe, there is no electrical connection with the support. So there is no need to install the cathodic protection system, because anyhow your pipe is not connected with the electrolyte. But just in case your insulation is failed, your pipe will be electrically connected with your support. And of course, the support will directly connected with the ground. Then the corrosion starting, then the cathodic protection will work. So just in case, come back to some our non-technical advertisement. Like, for instance, few years ago, I remember, if I'm correctly, there was one company trying to advertise the cathodic protection application to protect the body of the car. While we know the car is having at least four, right? Four tire, which is completely made of rubber, which is there is no electrical connection between the car body with the road. So actually the cathodic protection will not work at all. So it's just to cheat on us and bring the price up without the correct application. Sometimes happening. So we need to be strong enough to understand how it is work. Some company just trying to sell their product without actually giving an output to us. So if it is really required, then we better buy. But if it is not, we don't need to buy. Otherwise, it is just accessories. Chemical treatment. When we say chemical treatment, there are many types of chemical. It is nothing but like medicines. The chemical is added into the systems in certain dosage, which is, of course, the dosage came out as a recommendation based on the lab test or field test, a comprehensive test, more than one test of methods. And they are also evolving, the same like coating. Every day there are so many new products come and can be injected in continuous mode or batch or semi-batch. And the chemical will work in some different methods. There are some chemical work as a barrier, exactly like coating, laminate the metal and then not letting the metal to expose directly with the process. Some chemical modifying the condition, let's say decreasing or increasing the pH. Some chemical also working like cathodic protection to sacrificing. Normally, chemical consists of zinc. And some of them are commodity. Some of them are specialty. The thing that I would like to highlight here, the first, optimum dosage is a vital character. Many cases, if you are overdosage, you are wasting your money. But if you are operating under the recommended dosage, it's not only it is not efficient, but sometimes it's make it worse than you are not using at all. So we need to monitor tightly not only the dosage, but also the performance, right? So some mistakes occur in our field. Normally, we don't know what's the correct dosage. Second, we know the correct dosage, but we don't know the performance result. So it looks like from management side, yeah, we have our Excel spreadsheet and every day we monitor, but we don't know what's the meaning of the value of that monitoring. So we need to be more clever and updated. We need to attend a lot of courses or seminar, because every day there are new technology, how to monitor the performance, how to improve your chemical application. So if within 5 years we are not updating ourselves, so we are running behind. And also a different type of chemical sometimes causing or ineffectiveness of different chemicals means they are sometimes incompatible or causing some operational issue. So thorough and comprehensive study required before you are starting to inject the chemical. The one that I experienced, I remember in 2010, it was not me, actually, different department. They injected new corrosion inhibitors to our wet gas pipeline, and it caused a severe foaming. The foam really disturbing the interfaces between liquid and gas, between condensate and water, and then causing trip of the equipment and stop productions. So the production stopped for 3 days, and it cost us almost 100 millions production, deferment because of that. So why it is happened? Because of there is only one small mistake during chemical lab test. Yes, the performance is good to mitigate the corrosion, but they forgot to do the compatibility assessment against other chemical use in the downstream. That's an effect, we need to work in different disciplines. We need to cross-check one to another. Sometimes we think that our results, our work quality has already resulting something really perfect, but in reality, we forgot or we cannot see something which is other people can see. This is just example biocide. Normally to control the bacterial, even biocide has a different group, non-oxidizer, oxidizer, and has at least I know now, right now, probably between 10 to 15 classes of biocide right now. We have oxygen scavenger, which is also having different classes to scavenge the oxygen to reduce the dissolved oxygens in water, corrosion inhibitor, hydrate inhibitor, acid gas remover, pH neutralizer, and many more, actually. I'm just mentioning not all chemicals available in oil and gas, but what I mentioned here is only all chemicals currently available in oil and gas industry to mitigate corrosion. Some chemical is not related with corrosion mitigation. Some chemicals related with production, for instance, demulsifier, for instance, it's to separate, to support the separation between crude oil and water. So it is not here because we are not talking at this time. We are not talking about the chemicals outside of corrosion mitigation. All of here are all chemical which is related with corrosion mitigation. And this is how to deliver the chemical into the process. We have storage tank, normally in offshore, tow tank, stainless steel. And underneath we can see simple solar panel and to activate the plunger of the positive displacement pump of injecting the small dosage of chemical, normally located in the jungle where we don't have an electrical source. And we have gas driven as well. We have electrical driven, a lot of things. And in your top right, you can see a coil and a solid plug and coil to distribute the chemical directly in the center of the process. Okay, in order to improve the effectiveness of the chemical distribution into the process. So we just completed to mention, to describe and explain about material selection, coating, painting, cathodic protection, and chemical treatment. That's the most top foremost methods for the prevention. And in addition to that, we have 3 other facilities, process parameter, and mechanical treatment. Facilities design is talking about how serious we are and how deep we are analyzing the system before we are constructing the plant. So for instance, low point, that like sharp edge that cause water or solid trap. We try to, as far as possible, reduce the possibility of having that. But just in case sometimes it is not possible to eliminate, we can only to minimize, then we might have other, come back to the 4 method, the earlier, the one that I mentioned. Probably if we cannot avoid that, that lag has to be there. We already do our best, we minimize, but that lag has to be there anyhow. So then we need to try probably cleaning method to regularly clean. So the dead leg will not be forever dead leg. Or for instance, to select a higher metallurgy. For instance, the same dead leg effect to nickel-based alloy, of course, will give you a much longer lifetime of before failure happen, rather than you are using carbon steel, for instance. Okay. Or even you can apply internal coating, for instance. Yes, the dead leg there, let it be the dead leg trap the sand and water and water and solids and contaminants, but they are not touching the internal metal directly because there is a coating and so on. So sometimes we need to work to jive here and there, left and right, to adjust them all together between 7 methods to work together on resulting the perfect plan for us. And another thing, the one which is also famous, is talking about the water condensation in the gas. Dew point principles. If you came from chemical engineering, you learn a lot about the water condensation and dew points. When the temperature is decreased below the dew point, then water will condense. And when water condenses, then it causes a lot of problems. Then we need to ensure that the temperature always above the dew point. How? Normally we use heat treatment method. How? We can use steam. We can use electrical tracing and so on. And we can also play with the composition. There is a software called HYSYS, where you can study exactly in certain gas composition, in certain pressure, where will be the dew point. And from there, all efforts shall be done to keep the dew point temperature above the operating condition above the dew point temperature, so that water will not be condensed. And process parameter control, we talk about the battery limit. This is operation. If facilities design in design phases, process parameter control in operating phases, where every equipment has a battery limit. You need to understand the equipment design-based memorandum or equipment data sheet, operating envelope and procedures and guidelines to understand how to operate your equipment. There is certain flow that allowed, not below, not above. There is certain range. Also, there is certain range for temperature, for pressure, and so on. If we run or if we operate that equipment more than or less than that range limit, sooner or later will cause problem to your equipment. Then also the close monitoring. You monitor, for instance, for separation. We have a filter, and after filter, there's another filter, second stage, then there's another one, third stage, and so on. In the equipment data sheet will give you clear that the inlet has to be, let's say, 100 ppm of oil in water, not more than that. But if you violate, you fit that filter, the first stage, by, let's say, 200 or 300, much dirty water than it's supposed to be, then your filter will not work perfectly. As the result, at the end, your produced water will be off spec. Okay, so this is how we operate. So don't just operate, but we need to understand your equipment very well. It's the same thing. You need to understand your car, because every different car has different limit and different capability. Don't use your sedan in desert, or the other way around. If you are staying in a city where most 100% of your road are black asphalt, okay, then why you are using 4x4 car, for instance, and so on. Same thing. So the more you understand your equipment, the more understand how to operate, and then the highest result you will get. Mechanical treatment. There is hot treatment, cold working. Okay. And if I explain why one by one, I think I'm afraid I'm going to replace Mr. Bambang here. So I don't want to go too deep, but just mention here some example. Post-well heat treatment, stress relief, annealing, okay, periodizing, and so on. There's a lot of things here. And the principle is just one. Actually, to modify your material properties to become softer, sometimes to become larger or smaller microstructure size, and will affect your ductility, will affect your toughness, your material toughness, and then to result your desired properties and according to the process requirement. Some process requiring toughness, some process requiring not requiring toughness, some process requiring only abrasion resistance. So it's depend on what you need actually. What we need, then we modify according to our needs. Then the monitoring, just as I explained before, this is the way to determine how the corrosivity of the fluid on a specific environment. Corrosion monitoring, there are probes, coupon, okay, electrical noise probe, CEng, bioprobes, and so on. We can see there are some of them intrusive, there are some of them extrusive. I mean, can be applied from outside without put inside the system. Some of them even not requiring. You can see here there's a wireless one right in the middle. Some of them now very automated, connected you to the DCS, and even from your house you can monitor through your laptop nicely. You don't need to go to the field. Some of them still very manual. You need to send the technician over there to retrieve and read the data manually. So a lot of different, nowadays is totally different with 20 years ago. The more and more modern technology came. Inspection is the other way around. Normally inspection, if monitoring how to understand how corrosive your fluid, but inspection is directly monitor your metallurgy. Right? What is the thickness? What is the condition of your equipment? That is inspection. And come back to monitoring before is how corrosive is your fluid. It's a bit different, but inspection and monitor are working together. Inspection and monitoring data can be used together to support each other. If we are having more reliable data for monitoring, we can have a longer interval of inspection because inspection normally more expensive than monitoring. So instead of doing, let's say, once every year, you can extend the interval of the inspection into one every 3 years or into one every 5 years because we know we have some serial data of monitoring data which are reliable, proven to be reliable, and there is no symptom of having corrosion. Then why we need to have too often inspection? Then we can reduce. And there's a lot of different technology for inspection as well. Ultrasound technique, visual inspection, radiography, eddy current, phase array, and so on. And its technology has its own weaknesses and strength. And we can see also what to be inspected because the outcome that we are expecting will depend on the equipment we are using. If you want to see the subsurface damage, the equipment, the inspection equipment will be different. If we want to see crack, it's different in comparison. We want to see the metal loss. If we want to have a volumetric damage, it's different when in comparison to have a crack and so on. Even the direction, if we want to see what they call perpendicular to the thickness, is sometimes it's different when in comparison to the equipment to be used. If we want to detect the crack which is in parallel to your thickness, and so on. We can see X-ray, eddy current here. There is an intelligent peak. You can see in your top left, intelligent peak. This is inserted in the pipeline. Normally work with magnetic flux leakage or ultrasound technique. And you can see X-ray in your most right, and then in the middle you can see a dye penetrant test. Okay, in your last one you can see eddy current test, so on. And prediction, as I earlier mentioned to you, normally 90–80% to be done during a design stage in order to decide whether you go to CRA, corrosion resistant alloy, or whether you go to carbon steel. Okay, there are so many models, and recently the most often used model are ECE and HydroCore. But in the past, when I started my career 25 years ago, we are using more simple one, Norsok, Dewar Milliam, Prolet. Now it is no longer used normally because the recent one is much more sophisticated. And it is not stopped today because I heard in the same company they are keep updating their version with the new one, with the latest one, which now is the model capable to distinctive various different of damage mechanism. Before it was very simple, just CO2 or just Jenderal and so on. And then we can see the beauty of the corrosion model is it is garbage in, garbage out. Okay. Yes, they can help us, but please feed them with the correct and perfect or representative data. Because if you give them nonsense, they will give you another nonsense. And it will means nothing for us. And at the end, we are ending up with wrong design. It could be underestimated or overestimated. So whatever you data you loaded into the software will really determine what gonna be your result is. So we need to have a very careful and study before feeding them the data. And this lesson learned happening everywhere in almost every company in that I ever worked for. We are always having mistakes since beginning. As a result, the plan or the equipment was constructed from metallurgy, which is either too expensive or too cheap. And then at the end, we are suffering. And we are talking about corrosion cost. How big is corrosion? Just to give you a clue that this is a data 25 years ago. Now is much more than this value. So it is reaching, it was, I said because 25 years ago, it was reaching 3.1% of US GDP, which is equal to almost 300 billion US per year. And how big it is, you can compare. What's the meaning of 276 billion US per year? We can see, and it is happening in all industry as well. Not only in oil and gas. The thing is, if in US alone, it is close to 300 US billion. I'm talking about 25 years ago, not today. Okay, let's just assume it is still happening today. What it will be for the whole world is just only US alone, 300 US billion per year. And I cannot calculate it. Yes, some people say that it is close to 1.8 trillion US per year and so on. It's a huge one. So the clue is corrosion happening everywhere in all industries. And scientists say that corrosion never sleeps. Call it 24 hours, 7 days a week, 365 days a year. And we may have Christmas, we may have an Eid holiday, we may have a crisis or Corona, but corrosion are just the same, keep working the same way, no change. And it is similar with the aging process. You can only deaccelerate it, but not able to eliminate it. And many cases, production is always number one. That principles adopted by many organizations. As the result, they are late on reaction. The massive punishment has already happened, incident everywhere. So again, the corrosion is not an engineering. It's not a purely engineering. It is part of engineering and also arts. And it is requiring not only theory, but also a practical experience and continuous update required. Because if we are not updating, we are standing still. We are running behind. Okay, I think this is the end of the first presentation. So I think we still have around 42 minutes to finish up the second presentation, which is gonna be a totally different presentation with the first one. This is more into non-technical that will give you a picture about how we understand about the role of the material corrosion engineer and how is the prospect of the material and corrosion engineering in oil and in gas industries especially, and how to develop ourselves to fit the global needs. So let us start from the first picture. What are they? What is it? A colorful graph. You can see from left to right in the X ordinate. It's an age, 17 to 22. And you can see the right side, 60 plus. Oh, it's an age. It's a period. So everybody, I don't know, again, if God is willing to give us an, life until reaching 60 plus. So this is all the paces that everybody will pass, unless the God willing different thing. Okay. And we can see there's a colorful, red, blue, green. What is this? We can see there is a tagging there clearly. Okay. And we can see this is normally in average people in that group category prioritizing in their life. In the beginning, most of you now as a students, you are in the first category, 17 to 22. Well, you haven't think about money. You haven't think about different thing. Nothing, only two, knowledge and experience, but more into knowledge. But when you start to work, you are in the second phase. Then you started to think about the money, the green bar coming. Okay. And you think that, yes, I still need to update the knowledge, but not as important as in previous phase. And then you move forward into the right, getting closer to the right side, at the end when you are reaching 60 plus years. The brown and the black bar is become smaller, but never reach zero. What it means? It means until we die, we're still learning something. So don't stop learning. Okay. But then the other color came out, become larger. The blue part is become more and more. And then the red part, why the red part is not the highest one? Why the second right category giving us more higher red bar in comparison to 60? Because normally in 50 to 60 years old is the moment where we need money to support our family. But when you are reaching 60 plus, all of your dependents mostly already independent now. Your children has already finished school, and then probably in many cases, your parents also, if you are already 60 plus, mostly your parents either already passed away or your children are no longer asking money from you. You are living only husband and wife. So So the cost is decreasing. Okay. But why the blue bar is keep extending? Because of the, normally the more you are getting old, the more abstract. You want to be closer to God. You want to be what they call useful for younger generation. Then it increases. The blue bar increases much more longer than before. This is the way we read. And then common journey of life. You can see we start from top left. We can see here born. By only born, actually, we won the competition because you are the selected out of million. You can ask your biology teacher about it. And then at the end, moving to the right, follow the arrow. You can reach childhood schools, universities, schools, universities, first job, and so on. And then is it ending? No. Even there is no complete bar. You still actually continues, even exceeding this page. You are always in survival mode to sustain your existence until you leave this world. And then you can see there's a red color here. Normally, people always, think, oh, I want to have a dream job that give us, big income, and then to give us more flexibility of time and so on. And some people get it on the first try. Some people got it only after changing the job for 7 times or 10 times, or some people never got it. So different people, different cases. Okay. And the things to remember that it is not a straight line. Many cases, I just put an example three, what cross here. You experience a fail. You fail something. You experience a failure. But then the only thing you have to recover, and then you have to continue your journey. Because if you stop there, you will never be grow. You have to recover and continue until you reach your end of destination. So what's the definition of successful for you? You may think, you may agree or not, all of things that written here. Probably your definition of successful is not even included in this page. Some people wants to become rich. They don't care about others. Some people wants to become high educated over money. Some people just, thinking about how the power will affect their life. Some people more towards into religious. And could be the mixture. I mean, different people, even if you are brother and sister, or if you are brother in the same family, derived from the same father and mother, you may have different target and understanding about the successful. So in this case, it is extremely difficult to agree that you are successful, we are successful or not, because our definition probably different. So let's set our own target. So focus on ourselves. Don't compare ourselves with others, because our priority are different. How to improve ourselves? Focus on ourselves, compete with ourselves. Because if you compete with others, you will lose. The target are different. Always positive thinking. Don't hear something negative and stop yourself. Understand your strengths and weaknesses. Then do continuous improvement. Keep learning and studying. It's a never ending and never stop process. Always creative and find new ways. And learn from mistakes. Let it happen if it is already happened. Don't immerse on your failure, but came out from there and make it even for a best teacher for you, for your future. Never give up and balance ourselves. So if you associated with any company, you must, especially a multinational company, this is a very common principle. Plan, do, assess, adjust. This is a continuous circle that you have to do in your career. You plan something, you do it as per your plan, and then next you assess whether anything we are doing giving us the result as expected. Then continues to adjust to have a better achievement and replan. So it will always be, if you follow through this closed circle, it will give you a maximum benefit. Now we are moving toward more specific into oil and gas industries. Why? I see some, not some now, it's become a trend. Many of you likes to work in oil and gas. Why you want to work in oil and gas? This is how people understand and how people thought if you are working in oil and gas. Our lecturer think that, oh, okay, I am very proud because he's successful to become oil and gas engineer. So he must be very clever now. Now I just illustrated by, people who are now become even a very clever guy and then can do a math calculation and so on. And your junior, a year younger or 2 years younger. Oh, okay, my senior is like a Superman now. He or she working in oil and gas now. Okay. And then other people think that, oh, it's a dirty works, but the money is good, for instance. But actually, whatever we are thinking, you can see your parents, your neighbor, your society. In reality, the last 6 pictures in this picture, in this page, you are only working and working. The work can be in your table, the work can be in your field, It's a mixture between practical and theory, but it's nothing but working. This is what I can guarantee to you, that this industry is giving you a chance to continuously studying and updating your knowledge. So if you don't like, yourself to continuously studying and working, I think this industry is not suitable for you. Okay, so if you like stability, but the money come in easy way without breaking your head, then don't go here because you will suffer. So the industry, the oil and gas industry demanding you to continuously updating your knowledge, reading books, attending seminar, doing work in the field. So if you don't like reading books, if you don't like go to the field, if you don't like to cooperate with others and sharing your knowledge, you will not, most likely you will not be successful in this industry. And then career opportunity in oil and gas. We can see there is opportunities, there is challenge here. It's a good opportunity for us. Why? It's the most readily available resources. Okay, and still have long future. I know the renewable resources came, but I'm quite sure they will work in parallel. The new renewable resources will not completely eliminate this industry. They will still in parallel at least for 100 years. Okay, and there are needs, thousands of engineers every year. And to be honest with you, relatively the industry is giving a better salary than other industry. And one I can guarantee, which is proven by myself and many other colleagues of mine, it is internationally mobile. I met my close friend in US. I met my close friend in the middle of the jungle, which is, I don't know, very far away from my hometown. And we never know that we didn't know each other, that where were we until we met. Okay, I met new people here, and then after 2 years, I met the same people in totally different part of the world. So this is the typical nature of oil and gas, very internationally mobile. But never tell us this is giving us a very good industries. It is having also challenges. It's a very competitive industry. You have to keep upgrading yourself. It is a high technology, costly. So you need to see and to decide something clearly, and you need to be decisive on making a decision and take an action, because wrong decision could cause a significant losses for the company, and you may be fired, or you may experience a big incident directly from your action if you took a wrong decision. Okay, and it's a demand continuous development. So if you want to play safe, again, don't come to oil and gas industry. If you want to play safe, if you want to stay in house and money come easy, we better trading. Don't go to oil and gas industry. And you can see here, this is typical organization chart and why they are colorful, yellow and then blue and then pink. Just to highlight it, this is typical organization chart where corrosion and material integrity contribute. You can see could be as QA and QC, could be as integrity and inspection, or could be as a production operation supervisor, or so on. Okay, it's either in operation or in a project. Normally we are working, or in maintenance. That's why I color in a different color. And closer view of corrosion engineering. Again, there's so many circle here. There are two separate groups of circle. Just look at carefully. The left side is about the interaction of the different disciplines, and all of them contribute into the corrosion engineering. So the corrosion engineering is not a process engineering. It's not a metallurgist. It's not a material engineer. But in order to have classification or qualification as a corrosion engineer, you need to absorb different type of skills from different engineering, mechanical, electrical. We are talking electrical about cathodic protection. We are talking chemical treatment. We are talking about chemistry. And then if you don't know process, so you don't know about the dew point, you don't know about temperature, pressure, then you will lose. That's a process engineering. If you don't know a stress analysis, you don't know about the crack mechanism, you don't know exactly about the material, about mechanical engineering, you will not become a good corrosion engineer. Okay, and so on. Everything here is contributing. If you never know what's the difference between material and its characteristic, you will not become a strong corrosion engineer. So you need to study about other discipline also. And in your right side, it is more into the scope of the corrosion engineering itself. If you see here, some of them already explained in this presentation. Okay, I think most of them already explained. Okay, now, why I mentioned material metallurgy engineers career option here, because most of you came from material or metallurgy discipline engineering right now. Yes, am I right? Most of you now are students of material and metallurgy engineers. So these charts give you an illustration about the industry that is absorbing the metallurgy or material engineers. And this is not only oil and gas. You can see other industry as well. Mining, infrastructures. What is infrastructures? Means building road or building high building, for instance. They are also demanding material and metallurgy engineer. And what's the heavy equipment, education, okay, and others. So it is not only oil and gas. So if we want to limit our discussion into oil and gas, then we are talking only about the green. Is it green? Yeah. We are talking about the green pie. Then we again breaking down. So it's not only about the engineer who are working in ExxonMobil, in ENI, in Saffron, or in ConocoPhillips, in Medco, which is considered as upstream. Some company in downstream also playing, a part, which is quite significant. And petrochemical also demanding. Okay. And then service company like Halliburton, Schlumberger, or many other service company also needing your, uh, service. So don't worry too much. If you think that only Saffron, Total, Medco, ENI, or all big company you mentioned, actually there are hundred company that you never even ever heard that name, but they are demanding your service. Okay. Consultancies, EPC supplier, there are more than what you think. And job title could be different as well. So when you have a reunion 10 years after you graduated, then you will surprise. Yes, mostly all of you are working in the same, for the sake name of material and metallurgy. Yes, you are working in your area, but one become metallurgist, the other one become inspection engineer, the other one become cathodic protection, the other one more into coating painting. They are in the same group normally, 70 to 80%, I can say that all of these colorful position filled up by material engineer. And not always, because for instance, myself, I came from process engineering, but through experience and through the journey of my career and through I can say, destiny, company divert me to become a material and corrosion engineer. But in fact, I'm a process engineer. Then I became one of them. But to be honest with you, this is the world of material and metallurgist engineer, because the population is dominant from material and metallurgist rather than from process engineer or from electrical engineering. And this is a typical of work. And if I extend it, even if I add 10 more pages, it is still not enough. So many more. The normal scope, that job scope that we are doing as an material and corrosion. You can see, just to read the title, you can see and you can understand clearly that in order to do any scope here, it is demanding a multiple discipline engineering other than only adhering to one discipline engineer of material and corrosion. You need to understand about mechanical, you need to understand about chemistry, you need to understand about process, and so on. So this is the strategy for fresh graduate to looking for first career. Okay. 1, 2, 3, 4, 5, 6, 7, 8. 8 point. 8 point. Don't limit to this 8 point. You can add the point more than 8, longer than this 8. But if you can do this 8, it is actually maximizing the possibility for you to get the job easier. Okay. Why easier? Because I'm telling you, to be honest, it is not easy to get a job. 25 years ago, I found the difficulties, and I believe at this time it is even much more difficult than my generation. And getting far, your next generation will experience even more competitive. We have now AI, artificial intelligence. So they have started to replace a real human by AI. So the number of the job opportunities is become less. So I know it is not easy, but it is not impossible. It is possible. So these 8 points here just to give you, you know, more chance to get the job on the first time. You can see this is also combination about soft skill, hard skills, your relationships, and then your eagerness to not to give up and keep continue. Okay. And even for the experienced professional, if you see now you've been already, let's say 10 years in the industry, you feel like your career is stuck. Your position could not be up. Your income is stagnant. Then you will start to frustrated. Why? I keep learning, I keep studying, but my career is stuck, my income is stuck. What's something wrong with me? You can see. You just try to work all of these things, okay? Don't hear something negative. Oh, you know, you need what they call? We call it in Arabic wasta. I don't know how to say in English. Connection probably in English. Or in Indonesian language, we need orang dalam, kind of. Okay. So without connection, you will not grow. Forget it. So don't believe that. Trust me. Even if what you heard is correct, what's the meaning of trusting that? And then you stop trying. Still, you need to try your best. And mostly I said what they are saying is not completely true, because I have already seen some people who were not anybody, who were not somebody, who doesn't have what they call, who doesn't have parents, who doesn't have money in the beginning, but they are now successful enough because they work hard and they are smart. So work hard is not enough. You need to be smart as well. Then we are talking about successful in the beginning. We are talking about soft skill and so on. But at the end, attitude is also important. If you never trust people, if you never trust anybody, you never be able to work in a team. If you are arrogant, then you will feel easily satisfied and you think that, oh no, I'm clever enough. Now I just want to ask, and demanding something to the company without giving. And at the end, it will damage yourself. So knowledge and skills really are very important. But when your attitude is against your knowledge and skills, it's going to be end of the world as well. So see, integrity. Many people ended up with jail because of corruption. And they are actually, few of them are actually a brilliant engineers in the beginning, but they ended up with bad things. Why? Because the attitude are wrong. And again, you could be listening to something which is not beneficial and not really constructive. And rather than constructive, it is destructive. And you trust them. And then you immerse on your own belief. Then it kills your progress also. So again, attitude is another part. So you need to have also the attitude rather than building on the knowledge and skills. And this is famous Ikigai. You can see easily by searching in your Google or Chat GPT what is Ikigai. You can see there is a point in the middle where all circles are meet each other. This is a very theoretical, ideal point where all four circle, which is what you love, what you need, what you can be paid for, and what you good at are meeting each other. Meaning you like the profession and will need that profession, and the payment is good, and you are good at it. Okay, and whatever effort is just try to shift it into a into a single point were located in the middle. And I know some people, because of this reason, some people keep changing the job. I would like to sharing my knowledge. Nothing is impossible. I was graduated in 1999, and most of you were not born at that time. 1999 was a crisis, economical crisis, mostly in Asia, because of George Soros doing something really, tricky things, and then damaging Asia economy. And most of companies are releasing people. So just not trying to exaggerate here, but just to get the first job, I apply more than 100 jobs. And I was graduated with I was not the best, but good enough, I can say, top 10%, but not the best. And GPA, yeah, okay. I mean, 3.4, something like that, out of 4, which is okay. I mean, some people do some 3.8, 3.6. So again, I was not the best, but yes, still categorized as okay, top 10%, something like that. And I apply through more than 100 companies. And guess what? From 100 application, I think less than 20 who reacted to my application. And the other 80s, I don't know even until today whether I was misaddressed, and then the letter at that time, manual letter. It's not like now through email, through what they call website. At that time, it has to be sent through post office, through the hard copy letter. And then I don't know until now whether I was misaddressed or they just throw it to the dustbin. But only less than 20 companies who reacted to my application and call me for interview. And of course, my money, I was not working at the time. I was fresh graduate. My money was limited. I could not afford to attend all interview because I have to travel to some of them in Jakarta, some of them in Surabaya, some of them in different city and so on. So I attend probably not all, maybe 8 or 7 I attended. And out of that 8 or 7, only 3 finally accepted me. Okay. Some of them applied, some friend of mine applied more than 200. Okay. Just to get the first job. So just, to explain how difficult it was to get a job. I don't know. I hope you not experience the same thing with me. I hope your road will be easier with me than me. Okay. But this is what happened to me. But trust me, when you get the first job, all of your effort paid. So don't stop applying. Don't stop working on it. Okay. And then at the 10th year of my career, after I worked for 9.5 years, I got an overseas job for the first time through a very competitive process where the job was actually in one of the, not one, is the job was in Qatar for the largest LNG company in the world. The largest LNG company in the world, where 180 nationalities wanted that job. And I have to compete with many engineers who are graduated from top tier university. And I get that job not because I am better than them, not because I am more clever than them. No. It's just because of I'm trying. It's just because of I work in the field, experience enough on that. And some people better than me, probably they don't want that job because they want to stay in their comfort zone. They want to stay in their country. Instead of applying, they didn't apply. Okay. And maybe the moment is not correct. Some people are maybe just like me, but they less experience or too much experience. They decided not to take the over. But at the end, nothing is impossible. I finally joined there, and I stay for 12 years there. And really, it's changing my life. I can say more than 50% of my career development because of that company right now. So I will not be the person who I am now if I was not joined with that company. Okay. And the last point, the beauty and good, healthy professional relationships. Sometimes in your life, you never know. He became your boss now. Tomorrow, he became your coworker. Okay. And maybe 10 years from now, you become his boss. And again, next occasion, he recover and he again become your boss. Okay. But what I would like to tell you is the manager, U.S. U.S. citizen manager in my second company, who likes my performance during my tenure with the second company back to Jakarta, tried to contact me when I was working in my third company. He got released from my from the company, and he said that I still want to work, and then he is asking my support to get the job. And I know he is a good person and he is very capable on his work. Then I try to get him a job, even though finally the negotiation was not really well, and finally decided not to take the job. But it is never happen if you have a bad relationship. You trust people because of your good experience and performance, but if you have bad experience, you will lose trust. He will lose trust, and then will not be a win-win solution between you. So it's a very beautiful. Can you imagine if there are 100 people in a group helping each other like that? Job will be much easier rather than fight for yourself. Because actually, human are a social nature creature. So maintain your healthy and good relationship with everybody. One enemy is too many, but 100 friends are not enough. So if you think you have 1,000 friends and you think that you are what they call good person, and see, I don't have I don't know what to say, but you know what I mean. I have 1,000 people like me, but you have one enemy. That's too much. Try to make all your friends. Things to remember: even Einstein born as a baby, nothing special. And even the most active people and the least active people are having only 24 hours. So God is fair. God is not giving 25 hours to some people. So it's all the same, 24 hours for everybody. And there is no straight road for your success, to reach your target. And everybody has their own labyrinth, has their own way. They may end up reach the same place, but the whole journey will give us a different story. So you will have an identical road with your friend. Okay, and then help each other, support each other, teamwork, and then balance your work. Because if your life is not balanced, it's just delaying your failure. At the end, you will fail. Either you fell down sick, or your family break down, or your children lost somewhere, or your family lost somewhere, or your job lost. So balance yourself. Okay. So this is just additional. There are some methods that are using in engineering world: root cause analysis, cost over benefit analysis, work prioritization, risk assessment, total economical evaluation. Probably you are not familiar right now, but if you start after this meeting to find those information in the internet and learn about it, even before you get the job, it could help you a lot probably during interview, or it could help you a lot in your first 3 years of your career. And it can be implemented even in your day-to-day life. Okay? And don't forget to study, don't forget to learn. The more you read, the more thing you know. And the more that you learn, the more place you will go. And I prove it correct by myself. Thank you so much. This is end of my presentation. I think we have 2 minutes faster than our target.
Yes. Thank you so much, Mr. Riky Bernardo, for your presentation. It is such an insightful presentation that you give to us, and it is meaningful for us, of course. We have entered the Q&A session, and I will conduct my friend, Yura, to conduct the next session of Q&A.
Thank you, Jehan. So we now open the floor for question and answer session. And to all the participants, if you have any question, kindly raise your hand or submit your question through the moderator. And we will only accept 5 questions for today.
Okay, I'll leave it to Jehan to select the, see, one people is raising his hand. I believe who's his name? Danan. Danan Rashid.
Yes,
Okay.
Mr. Danan, you can open your mic and ask.
Okay, thank you for the opportunity. Hello, Mr. Ricky, and thank you for this opportunity to ask you a question that I've been thinking about based on your presentation. My question is maybe as we know, the economic state of the world is not very good right now because economic activities are declining, mainly because of the trade wars between America and China and the war in Ukraine. The main problems that are relevant to corrosion engineers are decreased export and import activities, resulting in less ships in need of maintenance, and the steady downward trend of the oil and gas industry in the last 2 decades. So my question is, what is the future looking for corrosion and coating engineers, mainly in the shipping and oil and gas industry? And how can we as Indonesians can try to get careers overseas? Thank you. That is my question.
All right, thank you, Danan, for asking. If you see carefully in view slides before end of the presentations, so becoming a coating, you are asking specifically about material engineers and coating engineers, right? So most industries demanding the coating engineer and material engineers. It's not only talking about oil and gas. We are talking about the mining industries. We are talking about infrastructures, which is keep developing. Okay. So if you are focused on, let me assume that you're focusing on or only targeting about the oil and gas. Okay, so let us not to make the conversation become wide. Probably you targeting oil and gas, if I'm correctly guessing.
Yes, sir.
Okay. So if you're targeting only oil and gas, based on my experience, I've been through at least 2008 crisis where the crude oil price crashes from 140 into only 30 US dollar per barrel. Okay, and all project stops. Okay. And then another one, 2015, where again crude oil price crash. Okay. So yes, we cannot avoid it. There is a layoff. There is you know a lot of projects were frozen, but we can see here that the demand is never stopped. The things happening was manpower reduced, and then probably no salary increment or no bonus at that year. But I can see that the demand of the material and corrosion engineer never stops. Okay, and even if the operating company not recruiting, still some engineering or some EPC, right? EPC, engineering, procurement, and construction company who build the plant are still recruiting, because when the crude oil price fell down, automatically the price to build a plant also become fell. And this is the moment where they are actually building a plant with the significantly cheaper cost. And the project is progressing because they know this is like a cyclus. After some years, the price will again, jumping. And they started the project and they approved the project with the cheaper price. Okay, so in overall, the effect to us as applicants, still it is giving us a chance and opportunity. So don't you worry too much about it. Okay, I told you I've ever at least 3 times experiencing this type of crisis with different reason, even including Corona last 2021, is it? Yeah, 2020. Still, yeah, I know it was not ideal for us. The salary is not really as good as before. Zero training, and then no bonus. Yeah. But I can say that as an oil and gas engineer, we are part of the profession where affected very last in comparison if you are working in a very downstream company like a biscuit factory or a food factory. They are affected even worse than us because the demand of energy is never stop. Okay, the demand of energy will never stop. I think maybe my answer, I don't know, satisfying you enough or not, but this is my answer.
Okay. Thank you very much, sir, for your very informative answer. And I'm very thankful for your answer. But I may have a few more questions, but I don't want to take the chance for other people to ask questions about your presentation and your experience. So, is there any contact information that I may get so I can maybe contact you to ask a few specific questions?
Yeah. Okay. So after this session, we'll share my contact numbers or all of the contact information, and also I will share the PDF file of my presentation to your coordinator today, so you can get it from your coordinator. So feel welcome always, anytime for you to contact me or just to text me or to send me email or whatsoever. So I'll be more than happy to be contacted.
Thank you so much, sir. That's all
You're
from me.
more than welcome. More than welcome.
Okay, Mr. Bernardo, there's a second question for you from Johnson Suripati. We've been approached by a foreign company who is offering us the solution of corrosion using the GRE, glass reinforced epoxy for casing or tubbing production. Have you ever experienced using this solution? And what about those high temp and high pressure? Any other choice of solution that we can get?
Okay. If I understand correctly, you are asking about the glass reinforced epoxy, GRE, as a lining for the production tubing. Is that correct? Okay.
That's
Okay.
correct.
So yes, of course, we are using a lot of GRE coating internally for tubing application, production tubing application. And they are limited up to around 90 degrees centigrade, unfortunately. Okay. So higher than 90 degree, epoxy will start to deteriorate it. And also GRE, which is epoxy based resins, is giving you a medium corrosion resistance. So, for instance, if you want to, of course, for the same temperature limit, let's say your temperature is lower than 90, but your fluid is much more corrosive than the limit given by the epoxy, then GRE. You can use a similar one, which is glass reinforced, but you can improve the corrosion resistance by vinyl ester, for instance. Or even there's another one which is recently very new, which is glass reinforced Novolac epoxy vinyl ester, that's giving you even much corrosion resistant. And if you want to increase the temperature resistance from 90 to become 120, for instance, you can use phenolic epoxy. So phenolic epoxy is giving you a higher, slightly higher from 90 to become 120 degrees centigrade temperature resistance. And what happens if your temperature is 200, which for instance, you may think not to use that kind of lining. We call it lining because this is internally. It's nothing but coating, but apply internally. Okay, GRE, GRVE, GR Novolac epoxy vinyl ester, or even phenolic epoxy. If the temperature is higher than all of the organic coating, why they are all organic? Epoxy, phenolic, vinyl ester, they are all organic. Then right now it's either using non-organic, okay, which is inorganic coating give you much higher temperature resistant than organic coating, or forget about the coating. Change the production tubing into higher metallurgy. Don't use carbon steel. You improve your carbon steel production tubing, like precipitation hardening 74, 17-4, or 13 chrome alloy. They may no need coating, but much higher corrosion resistant than your carbon. And at the end, if you're still not enough, your 17-4 or 13 chrome, you can go with Inconel 625, for instance. This is a pure nickel-based alloy with around 65% of nickel. This is no longer ferritic alloy, no longer what they call, no longer Fe alloy, but more into nickel-based alloy, because the majority of the constituent is nickel right now. It is giving you temperature resistance even up to 400 degrees centigrade, and you don't need even coating. It will not be corrode. So there's, like I told you in the beginning, there's a combination of coating. There is combination of various different what they call prevention methods. So don't rely only on one side. Don't stick only to coating because you are only coating guys. Then you don't study about material selection. You don't study about the chemical treatment. You have to combine all of your knowledge in order to become a powerful corrosion engineer. You need to understand all aspects. Okay, so there's not only coating.
Okay, Mr. Bernardo, thank you for your answer. And there's a third question from Dava. Since corrosion engineering is usually considered a sporting role, unlike drilling and or sales engineering that are more directly tied to business result, do you think there's still a good chance for a materials or metallurgical engineering to make it to top level management? Thank you.
Okay, so you are targeting to become CEO, it looks like.
Nice.
Okay. We never know. Based on my experience in different organization, yeah, I mean the person who hold the title as a bachelor degree of metallurgy or material engineer, I think whom I know the highest one only senior manager. I don't know, maybe I'm not living long enough to meet such kind of people. So most people either having a process background or subsurface like petroleum background. In oil and gas industry, I'm talking. I'm not talking in different industry. But what's the meaning becoming CEO or senior engineer? In oil and gas industry, the remuneration having two different road. One is the career path, the other one is the what they call technical part, technical ladder. You may have the same grade, and the salary are almost typical. If you are a specialist, let's say you are a chief engineer or as we call it custodian engineer versus the vice president, which is having 1,000 people working for you. And as a custodian engineer, you may have only 2 people working under you. But the grade are the same and the salary is not far different. Yes, still there is a difference because there is what we call allowance for the position to become manager. But let's say if the allowance is 15 to 20%, so means that people having the same grade because 1,000 people reporting to him. Okay. And you have only 2 people, but your salary is 80% than him. So what's the problem to me? And don't get mistaken. Dealing with people is not as easy as you think. Sometimes dealing with people is more headache rather than dealing with technical. So it's again your preference, and again maybe I'm not live long enough to meet such kind of people. Probably there are some people whom I don't know and I haven't met with. This is my point. Yeah.
Okay, Mr. Bernardo, there's still uh, a question from Muhammad Yakub. What does impact green energy for and gas industry for the next coming 20 years?
Green industry. All right. It's again a very general question and quite, there's no definite answer. I mean, it's very dependent on where you are. Okay. The answer from that question probably different if you are living in, let's say, in Norway, okay, in Scandinavia country, where they are, mandated by the government. So the government really endorsing the green energy because of they don't have now. They have now. I visited Norway last time, not even 2 years back, and there is no car fueled by diesels or by petrol. They are all now either hybrid and purely electrical, and they try even the next 5 years to eliminate hybrid to be pure electrical. Okay, and Norway has around 3 million barrel crude oil. So they keep still doing exploration and production, and they sell it, they export it, and they took the money, but they use the money inside their country for totally green energy, for instance. But China and India don't care. China and India don't care. They said that if there are many other countries are violating, why I'm care to use the dirty. They call it as dirty. I don't know, because don't think that green energy is having a zero what they call carbon foot finger. No, it is not that way. Okay, they are still actually resulting some contamination as well. Okay, so if you learn carefully, green energy doesn't mean zero contamination or zero pollution. They are still, but they try to minimize. Okay, but again, in Indonesia, I think we are far away from Scandinavia. You know our condition and situation. Middle East, for instance, Saudi Arabia right now producing around 10 to 15 million barrel and become the largest oil producer in the world. And I know they have a reservoir which is still enough up to 80 to 100 years. So if the cheap energy and readily available with cheap lifting costs still available, I cannot imagine if they are suddenly stopped and just wasting their resources and jumping into something else. Like I said during presentation, probably both green energy and fossil energy will still in parallel used together for 50 to 100 years. It will not be 100% eliminated. And anyway, I'm talking about this. My son is working in a green energy company. So he is working in Belfast right now in Northern Ireland, and we are always fighting every day. Okay, so I'm quite familiar with the green energy and the way they are targeting the market.
Okay.
Thank you for your answer. And there's still one last question for you, Mr. Riky Bernardo, from Anissa Yudiam. Dear Mr. Riky, I am a fresh graduate. I want to start my career on material and corrosion engineering field in oil and gas company, but my previous educational background in material engineering was focusing on polymer field. If I want to switch focus, do you have any advice of how I can start? For example, certification, course, or even suggestion for taking corrosion master degree, since most of the entry-level job also requires portfolio in related field and corrosion topic during the final project.
Okay, well understood. It's a very good question. I can give two alternate options. The first one is non-polymer is one of the subject which is also demanded, and I know I have quite several good friends of mine who are graduate as a non-metallic engineer. And I know there are some job opening in largest oil company in the world. Until now, still not filled as a non-metallic specialist. So think about it. I mean, still an open opportunity even for non-metallic engineer to be recruited. Okay, but just in case you are pretty sure that, oh, no, my option is actually I want to go to become metallic engineer instead of non-metallic engineer, then what will be the certification required? Okay, so first of all, again, apply for the job and follow the line where the company took you. Okay, we don't know what will be your first employer. You could be accepted in cathodic protection related company, and someday you'll be shifted into cathodic protection engineer. You might be recruited by chemical treatment company and you'll become a chemical specialist, or you may become still non-metallic, or you may become, if you are accepted by metallic related, then automatically they will divert you there. So it's very depend on where your first employer is. Okay, And from there, you can see and feel also, depending on many aspect and prioritization, you can consider whether you continue your career to extend longer into 5 or 10 years in that company, or you can shift it when the situation become better into operating company. So there's a lot of option in front of your life. So don't worry too much. Even if you focus
Yeah.
on non-metal, there will be opportunity.
Agree. In coating field also, it is possible
Yeah,
to take a
very
career.
fun. Great. I have a
Mm.
friend working in I don't know it's good or not to mention the brand, but it's better not. I think he travel around the world.
Yeah.
Yeah, I don't know about the income, because income is a very specific topic, so I don't want to talk also about the income. But he travel maybe as much as twice in comparison to me. I mean, he moved around the world and easily to get a business trip.
Yeah.
And he is cutting engineer. And guess what? The background? Civil.
Yeah. Of course.
So,
And
see,
at the
we don't
same
know.
time, if she has the interest in corrosion protection, for example, she can learn deeply, in this field.
Yeah. Of course. And when you get the job on metallic, you will have my contact number from your coordinator, and you can ask again your second question to me. Then I will relate you with a lot of training courses and certification
Yeah.
required. Don't worry.
Okay.
I think if I can given a chance, there are some non-Indonesian here joining with our presentation today. So now we will give one chance for anybody not from Indonesia to raise any question. If nothing, then I'll return it back to you, Jehan.
Yeah. Okay, Yura, it's finished.
Okay, thanks for all the questions from the participant and the insightful answer from Mr. Riky Bernardo. So now we will end the Q&A session, and I return to Jehan.
Okay, thank you so much, Mr. Ricky Bernardo, for your new insights, new knowledge that you've given to us from answering those new questions. It is such a great new knowledge that we know right here. Before we end today's event, we would like to present a token of appreciation to our speaker and guests. That's why I would like to invite our advisor, Professor Dr. I.R. Bambang Widianto, DEA, our chairwoman, Keisha, and our honorable speaker, Mr. Ricky Bernardo, to join us on the screen to present the mementos.
Okay. So Uh, Jihan, it's okay. It's already.
Yes, we are preparing for the certificate appreciation that we can give to Mr. Riky Bernardo.
Oh. Okay, for Mr. Riky Bernardo, first of all, I would like to thank you for your presentation. It's very, very nice, and we have many participants in this event. So I hope this relation will continue for the future, and maybe you can come physically to Unyani to give a lecture, maybe short lecture. But maybe we wait, yeah, Jehan, when Mr. Ricky will come to Indonesia in
Yes,
holiday, for example. So,
sure, we're waiting.
yeah. So for this certificate, we will send to you by email, yeah, Jehan. And thank you very much for this nice presentation. It's very useful for us, and I hope that it give many idea to the student, also many motivation to the student, maybe in field of corrosion especially. So thank you once again, Pak Ricky, and see you again in Indonesia.
See you. Thank you so much. It's my honor. It's my
Yeah.
honor. I'm more than happy to do that. Thank you.
Okay.
We'll see you again, Jihan and Tim.
Uh-uh.
Thank you.
Okay.
Sure, thank you.
Thank you.
But before we end today's event, we've come to the end of the program. After this, we wanted the participant to turn on their cameras and take picture with us for some documentations
Yeah.
purpose.
Okay. For all participants, open your camera.
First slide, 1, 2, 3. Okay, you're captured. Second slide. Make sure to turn on your cameras. 1, 2, and 3, smile. Okay, you're captured. Third page, 1, 2, 3. Okay, captured. And the last slide, fourth slide, make sure to turn on your cameras. Okay, captured. Ladies and gentlemen, we have now come to the end of today's program. On behalf of the organizing committee, I would like to express our sincere gratitude to all speakers, guests, and participants for making this event such a success. We hope today's event has been insightful and valuable to all of you. Until next time, stay safe and keep learning.
Okay, Pak Ricky. Have a nice day in Qatar.
Have a nice day.
Maybe if
Thank you.
I pass to Qatar by airplane, maybe I can give you a sign.
In Muscat,
Okay.
Pak. Doha right now. Sorry, Muscat, Oman.
Oh yeah. Okay.
In Muscat,
Okay.
Oman.
See you.
All right.
Thank
Bye.
you so much, Mr.
Bye.
Ricky. Professor Bambang,
Bye.
thank you so much.
Okay.
Thank you
Thank
so
you.
much.
Bye.
Thank you.